So today we are going to learn something about analysis of variance, which is our next topic in the course number AGB 605. So in the earlier lectures, we have already studied something or revised about the basic statistical tool which you are or we are supposed to use in breeding. Again, we have already seen about the matrix, basic operations of matrix, addition, deletion, multiplication, and determinants of the matrix, how to calculate determinant, and how to inverse the matrix. So, एक मिनट हाँ, एक मिनट resume the call. So earlier we have already studied about matrix, inverse of matrix, how to calculate, how to estimate the determinant of matrix. And now we are going to switch over to the next topic, that is analysis of variance. This is very common term which we have already studied in our UG life. But still, as a breeder, as a genetician, our main aim is to identify the variation in a population. And whenever the variation is there, at that time we have to understand the or we have to estimate the variance. And now we know that the variance is not only due to one cause. There are several sources of variance, isn't it? So that's why we have, as a genetician, we have to identify various sources of variation. Again, how much variation is being caused by which cause or which factor, that we are going to estimate. And all these things are to be studied under this concept, analysis of variance. The word itself is a self-explanatory. We are going to analyze the various sources and the variation caused due to that sources. So we know that as a part of this, means considering the objective of this class, we are again going to understand the concept of variation and variance, and the procedure for the ANOVA. Anup has been joined right now. So Anup, we were discussing, just we have started our meeting. We are going to learn in this class, in this module, about analysis of variance, which is a very important tool to understand. And with these objectives, we are going to discuss about this topic to understand the concept of variation and variance, and again to know the procedure of ANOVA. Very simple two objective which we are very much familiar with that. Considering the introduction of this topic, the concept of ANOVA was given by Ronald Fisher, or R.A. Fisher, who was basically a mathematician, and a very famous book, Statistical Methods for Research Worker, he has wrote. And in his book, he has mentioned various tests and various tests of significance. So here, the statistical methods to estimate the or the analysis, that estimate the analysis of the difference between the group, among the group, in a sample, that has been described thoroughly by this R.A. Fisher. So we used to say that this ANOVA is basically based on the law of total variance, which provides a statistical test whether two or more population mean are equal. So what is this law of total variance, that we are going to look in the next study in the next slide. Then testing of hypothesis of equality among the several means. So this was the what we can say the genesis of this putting up the concept of this ANOVA by Fisher. Now we'll try to learn one by one. So we know that variation, whenever we are discussing about variation, we know that in the what we can say in the nature, we are looking so many type of variation. For example, I have shown two pictures. In the left picture, we can found a variety of iris color, isn't it? And in the right hand side picture, just a simple trait, height of a person I have considered. So we can found number of traits in the nature, not only in animal but also in the human being and in the plants and all in animal. So we are finding the variation with respect to some traits. So we can identify the traits or categorize the traits into two ways. One may be the qualitative trait, another may be quantitative trait. Qualitative traits means which such traits which we can classify into different grades, into different shades, into different classes. And another is a quantitative trait which are used, means which are measured by some metric units. So these are the quantitative traits. So for these two type of traits, we used to find two different type of variation. For qualitative traits, we are having a discontinued type of variation because these are the classes, isn't it? So blood group, for example, AB blood group is there, A is there, O is there, B is there, likewise. So these are different classes, we can say qualitative trait. However, height, if suppose we used to consider, this is a, it shows the continuous variation, isn't it? So this is the simple concept of variation with respect to type of traits. Then you might be remembering this curve, bell-shaped curve, which is a normal distribution curve or a Gaussian distribution curve. And this thing we have already covered, that a normal distribution curve, any biological event or the observation or the data, it is following such type of, roughly the bell-shaped curve is following. And we know that mu is the population mean of this uh, curve. And if it is a normally distributed, then we know that mean, median, mode, they are lying on the central axis of this curve. And on the both sides, right hand side and left hand side, these are sharing some part which is what, for example, if suppose in this graph, if it is 100%, then we can say that if these are the, this bell-shaped curve is covering all the hundreds of the, or all the observations. So out of total number of observations, about 68.2% of observations or the values, they are lying within the range of 1 sigma. 1 sigma is a standard deviation. This type of equation symbol is a standard deviation. So now we know that the deviation from mean, 1 sigma deviation plus side and 1 sigma deviation minus side, standard deviation. So that's why it is called a standard deviation. So this part is encompassing 34.1, 34.1 on either side, means totally 68.2% observation are falling in this range or in this region. Again, if we suppose the 2 sigma distance, then here we can found again 34.1, which were covered in the first sigma or 1 standard deviation. Then another is a word in this second part. So that sigma, 2 sigma distance, so that is going to cover 95.4%. Okay, am I audible to all?
Yes, sir.
Okay. And if we suppose consider the 3 sigma distance, so it is going to cover about 99.7% of the total data. So any biological activity, this will follow this kind of normal distribution curve. So now how it is concerned with us, we know that normal distribution curve and animal data, if suppose we are concerned, we know that ours are the traits of economical important, maybe milk yield, maybe meat yield, maybe egg size or egg number. So all our animal breeding data, this is pertaining to specifically the economical important traits. And another is a sample size. We have to consider different sizes of sample so that we can have a better or the mean value which is moreover nearer to the population mean. So here the central limit theorem is that if suppose we are considering the large sample size, so it means that if your sample size is much larger, then mean of all the samples, this is nothing but the mean of population. These are representative of mean of population. So provided that when you are saying about the samples, so you are considering the individuals taken randomly. So this is the central limit theorem. We'll see in the next slide. And again, this concerned with the normal distribution curve, we know that the mean is indicated by mu sign and standard deviation as a sigma sign. And we know that standard normal distribution, which is executed as a z, it is nothing but the xi minus mu upon sigma. This is the formula to estimate the standard normal distribution. So this part we have already covered in our graduation. We are just revising it because much period has been lapsed between your genetic course in graduation and in this post graduation. So here sigma is nothing but the standard deviation. Then when we square the sigma, so sigma square is nothing but the x minus mu whole square upon n. So here what this formula itself is indicative of, we are considering the deviation from population mean. Mu is a population mean. X minus mu is nothing but the deviation from the population mean. So we are considering the square because why? Because we are having some values which are more than the mean value and some value which are lower than the mean value. So some are in positive way, some are in negative way. That's why to have a modulus effect, we are going to square this deviation or difference. And that's why whatever is the standard deviation, so square of the standard deviation, nothing but the variance. So concept of variance, if suppose we are considering the law of total variance, what it indicate? Where the observed variance in a particular variable is partitioned into component attributable to the different sources of variation. So whenever we are considering the variation, it may be between the group or among the group, isn't it? So what is our role? What is the role of a breeder is to separate the variance ascribable to one group, which is causing from variance ascribable to the another group. So what is the role of a breeder is to identify what is the variance occurred, observed between the groups and within the group. So in this context, we are will see this one example. For example, this dark blue color circle is a population. For example, this is a population of whole district, population of cattle in a whole district. And if suppose these cattle are what we can say, considering the three different breeds or three different strain, we are going to segregate them into different sample size. This is one sample size, this is another sample size, or this is another sample size, which is executed by three different colors. So now we know that this, when the original population may have its own what we can say mean. For example, the mean milk yield of all this herd mean, it may be, for example, 10 liters. And here are certain cows, for example, this green color code, this green cow in this green circle, this may be high yielder, this may be medium yielder, and this may be low yielder. For example, with respect to their yielding capacity, if suppose we are going to estimate the mean value, then we may observe differences between, or even the if you are taken three different groups in a different randomly, so we can observe that there is a difference between the mean value of each and every group, isn't it? There will be difference definitely, because the population size in each sample may be different, or the potential of every animal in the separate group may be different. So all these three samples may, or they will show the differences in their mean value. So to this difference, we can refer as between group variation. Are you getting this? So this is the difference between the three different size samples. This is giving us between group variation. And suppose consider this only one circle or one blue color small sample size. Again, we know that all the animals in this group are not able to deliver equal quantity of milk yield per day. So there may be variation between the or within the group, isn't it? So what we are facing, we are facing two type of variation. One is within the group, another is between the group. We can correlate this with our college, with our school life. For example, this is a population of 10th standard students, and these are the class A, class B, and class C. So definitely, in with respect to percentage, we used to find differences in the topper, first rank holder, second rank holder. So for example, we can say on an average, the mean value of each class is different. Again, within the class, the percentage received to the student, secured by the student, are different. So here we can correlate the group variation as a between the group and within the group. So I think you are getting all this thing. Now just say for example, whenever we used to found any a small child, how it's behaving with a new thing. For example, if a new thing is put in front of a child, what will be the reaction? You can demonstrate with our the child or the little babies in our family members also. So what the baby will do? He or she will first of all observe it. What is that? Then it will try to catch it, try to eat, try to smell, try to see. Likewise, so the baby will form a hypothesis. It may be the thing to eat, isn't it? It may be eatable, something chocolate or likewise. So what the baby will do? It will try to have a experiment, isn't it? So it will try to eat. Then after eating, he or she will realize it's not a sweet, it's a bitter, or it's a sour tasted. So she or he will try to cry. And then again, if suppose another baby comes in front of him or her, it will show to her. So in the same fashion, a scientific method we can imagine. First of all, what we are doing, we are making a observation. Then we are forming a hypothesis. Then we are performing the experiment. Then on that basis of experiment, we are analyzing the data. Then we are reporting our finding, and then we are inviting others to reproduce the result or for research, isn't it? So if we are getting this picture, or I think you will be able to know about the how is the scientific method of doing experiment. Now here, this stage number 4 is very much critically important, because this is the bridge between, or this is a pool between this third step and fifth step. If suppose you are not able to analyze the data properly, automatically your reports will be misleading or faulty reports. Faulty findings may be recorded, and it may harm to the next researcher. So likewise, we have to consider about the testing of hypothesis, how we are going to test the hypothesis, just as the sequence we have already covered: observation, hypothesis, experiment, data collection and analysis, and then communication. So we are following the same fashion during our research also. So another concept, another new term is the hypothesis. This is well known to you. Hypothesis means what is the imagination, what is the conception of the what is in the mind of the researcher. So there are two types of hypothesis. You are knowing that: null hypothesis and alternate hypothesis. For say for example, a new dish, we are presented with the new dish. So after observing, we may imagine that, so this is a round color and sweet, seems to be like a rasagulla, so definitely it may be a sweet dish. So this is our hypothesis after observation. So this is nothing but the alternative hypothesis. Alternative hypothesis means that hypothesis which researcher tries to prove. Researcher is intended to prove, inclined to prove. Another is a null hypothesis, which which the researcher tries to disprove or nullify, which he don't seem that after administration of this and this drug, the body weight in the poultry will be raised. So this is the hypothesis of a researcher. But after giving this drug, the another possibility may be there. Okay, body weight may not be raised. So this is a null hypothesis. So friends, we know that there are two types of hypothesis. One which is in favor or the how the researcher is thinking. So that is an alternate hypothesis. Another is a which is disapproved by, which is not accepted by or nullified by a researcher. That is a null hypothesis. And that the thing we know that after testing the hypothesis, how we are going to suffer with the type 1 and type 2 type errors. And for example, acceptance of the null hypothesis and rejection of the null hypothesis. We know that rejection of null hypothesis, if it is true, then we used to indicate by alpha value. Acceptance of null hypothesis, if it is a false, so it may be also beneficial to us. So that is a beta. This is nothing but the portion which we have covered in our graduation. So there are two types of analysis or classification of the means. There are one-way factor and two factors classification means. So what are these? In ANOVA, what we are doing, because say for example, our any trade, consider any trade, milk yield. So number of factors are affecting on the milk yield: age of cow, lactation order, season of calving, even the health status of animal. So you can imagine so many factors are responsible for expression of the milk yield or the production of that milk yield. Even the breed variation or strain variation, genetic constitution of that animal is also governing a major role. So here, as a breeder, what is our role? We have to segregate, separate the sources of variation, and then we have to estimate what are the sources of variation, and these different components of, or these different components, how they are having a differences in their mean values if suppose they are studied individually. So in ANOVA, we are considering all the factors at a time. So that's why first of all we are calculating the correction factor. So this is total number of n is a total number of observation, and t it is we know that it is a sum of all the values. So we are taking the square of all the values divided by n. Then we are following the column sum of square and row sum of square. These things it is presented in our Pactel manual. I hope you have gone through it. And then on that basis of column and row sum of square and this correction factor, we are going to estimate the total sum of square, and then at the last error sum of square. And then all these values we are putting in a systematic table, that is sources of variation, considering the degree of freedom, sum of squares, mean sum of square, and then we are calculating the f value and trying to estimate this f value, compare this f value with the table value, which is given by the statistical table. So first of all, we are considering the between row variation, then between column variation, or even we may have a interaction between the this factor A and factor B also. So depending upon the number of rows and number of columns, we are calculating the degree of freedom. We know, you all know that this n minus 1. So this is a formula of calculation of degree of freedom. It is nothing but degree of freedom means, for example, there are 3 treatments. So after selecting one treatment, how many are the choices to you? So you can process your experiment with only 2 treatments. So this is nothing but the degree of freedom. How much freedom you have? You can, after selecting one, you can select only 2. So that's why it is n minus 1 or 3 minus 1, 2. So this is nothing but the simple ANOVA table. We are going to estimate the values with respect to all the ANOVA, all the numbers arranged in a rows or in columns, say column pattern, and then on this basis we know that this row sum of square, column sum of square, and error sum of square. So when we divide the row sum of square with the error sum of square, we are getting the this mean value, isn't it? Mean sum of square. So, and on that basis we are calculating the f value. So this is a ANOVA. This is something about ANOVA. I think uh, although we have hurriedly covered this thing, but the major intention was to convey you about the concept of variation, concept of hypothesis, the arrangement of the ANOVA or ANOVA table, procedure of ANOVA. I think these two objective, which we have already mentioned in our first, second slide, so that has been meet the need. Here there are assignments to you. I hope you are doing your assignment, which are provided in every class after the end of every class presentation. Oh, you have to read out the theory and procedure of ANOVA described in our practical manual. I have already circulated it in a soft copy also, by email also. And then you have to try to solve the problems in that practical chapter of ANOVA. This is one assignment. Another assignment is to find out what is meant by ANCOVA. Just like analysis of variance is there. So I think you are knowing this thing, analysis of covariances and analysis of molecular variances. So you can find out this analysis of variances. Hello, hello.
हॅलो.
हा, अनुप आवाज येत आहे का रे?
हो सर, येत आहे.
हो सर.
आणि हे दिसत आहे का स्क्रीन?
हो, स्क्रीन दिसत आहे.
ओके. Stop sharing. So, am I visible to you?
येस सर.
तर आजचं जे सांगितलं ते समजलं का रे बाबा?
हो सर, वाचावं लागतंय सर अजून एकदा.
वाचावं लागेल ना. एक मिनिट, हा, एकच मिनिट. स्टॉप.